Welcome to our video on basic electronics. So we are going to do a very simple video today about how electricity works to light up some simple lights. We'll also talk about resistors, breadboards, and just some basic concepts around circuits. So when we're dealing with electric circuits, we need to understand, first of all, electricity. So this is a simple battery pack, and our simple battery pack represents a store of electricity. Right? That's what we use batteries for, to put into our remote controls, our RC cars, whatever it is, to power something. You can lots of times think of electricity similar to water. In the old days, water was used a lot. Moving water was used to power things. Maybe they had a water wheel in a creek, so they'd run water over this wheel, and that wheel would turn and run a sawmill, a grind, something to grind corn or make mill, whatever kind of things that is. We use, and we still today, we use giant hydroelectric water dams. We use the movement of water to create electricity. But my point here is to understand that electricity is really the flow of electrons. And you can almost think of that flow of electrons like water moving. And in order for electricity to do anything valuable, we want it to do some work. So just like that water flowing over a water wheel, we want our electricity to do some work. In order for that to happen, then we need a way for that water to flow, or that electricity to flow. And electricity flows through typically wires or some sort of conductor. Most metals, a lot of metals are good conductors. Copper metal is a great conductor and used in a lot of wires. But all electricity has to have a source. We're going to be working with these batteries as our electrical source. So they're going to provide electrons. And if you know, batteries have a positive and a negative end. If you've ever tried to put batteries into a remote, whatever, you know, you always have to put it in the right way. And that's what these wires represent. The red wire represents the positive end, and the black wire represents the negative end. So water, or our electricity, has to flow through a path, and electricity always needs to flow from the positive to the negative. So we're always going to be flowing in a battery pack from out the positive into the negative. So to show that, I have a simple little LED. LED stands for light emitting diode, and what that means is this thing can emit light if you hook it up the right way. That word diode, you don't have to worry about it too much, but that word diode really means that electricity can only flow through it one way. So what you'll see here is if I take, it's kind of hard to tell maybe with this one, but this leg is a little bit shorter than this leg. This leg here is just a tad bit longer. And this lets us know which is the positive and which is the negative. This is the positive side of the LED. So if I take my negative side and hook it to the short leg, just touch it there, and I take my positive side and touch it to the positive leg, you see I get the light to come on. I just touched it for a second because it gets super bright. So there you go. So positive going to the long leg and negative going to the short leg, and I see a little flash of light. Actually, if I held it on there, it'd stay on for a long time. I'm going to switch it around. Now if I take the negative and hook it to the long leg and the positive to the short leg, nothing happens, because electricity can only flow one way through a diode. But so this is a light emitting diode. It's a simple light. Now a light bulb, it wouldn't matter which way you connect this up, but LEDs do matter which way. So positive to the long leg and negative to the short leg. Now you notice that is super bright. So what we have is this battery pack has 3 AA batteries. Okay, and if you didn't know, AA batteries are 1.5 volts. Volts are how we measure the pressure. Think of it again as water. How fast that water is moving through, or how much pressure really. It's not how fast it is, it's how much pressure is behind that water. Imagine you have a hose, a water hose, and you put your thumb over the end of it, you can increase the pressure, right? So volts is the way we measure pressure. And I don't know if you can see it real well on the camera, but this says 1.5 volts. AA batteries, AAA batteries are all 1.5 volt batteries. We have 3 of them working together in what we call series. Basically, they're all connected together So you add the voltage. So we actually have 1.5 volts plus 1.5 volts, which is 3 volts plus 1.5 volts. So this is a 4.5 volt battery pack. So that means we have a decent amount of pressure coming through this light. And as you can see, it's making it really bright. Now, let's say I wanted to make it not so bright. How could I decrease the flow of electricity? So basically kind of slow down that electricity so it's not quite so bright. Well, that's where resistors come into play. Just imagine you're holding a hose and you're squirting a lot of water through the hose, and then someone kinks that hose. Then the water starts trickling out. That's kind of what we're going to do with the resistor. Now, before we do that, before we hook up the resistor in this, I'm going to show you this is really hard to work with an LED just laying and taped to the paper. That's why we have what we call a breadboard. Now, back in the day, the reason this is called a breadboard is a long time ago when people were working with electricity, they used to have in their kitchens a wooden board that they would actually cut bread on. Had nothing to do with electricity, just in their kitchen. Lots of times bread would not come pre-sliced as it does today. You'd make your own bread or you get a big loaf and you'd have to slice it yourself. So they had these wooden boards that people would commonly use to slice bread on. Well, when people started playing with electronics, they would actually put little screws in those breadboards and run wires around them and create their own little circuits on a breadboard, a board usually used for cutting bread. Well, we don't have too many breadboards today, but we still have a lot of people working with electronics. So they developed something that's a lot simpler than screwing screws or hooking wires up into that breadboard. They create these little things. They still call it a breadboard, but it has nothing to do with bread anymore. It really is just about having these little holes that I can plug simple electronics into. So let's look here. If I plug this positive, this long one, if you see it, this is the long one, I'm going to put that into this row 15. And then I'm going to put the smaller one into row 13. Okay, so row 15 is my long one and row 13 is my shorter one, the negative one. Now, each of these rows are connected. I've got a little picture here showing a breadboard. This is a longer version of what you see, what we have. This is exactly like the one we have right here, but this bottom picture is showing how it actually works underneath. If you took the bottom off of the breadboard, you'd see it's a bunch of metal that's all connected. So the power, we call these the power rails, the blue and the red. The blue here represents the negative or the ground, and the red represents the positive. So all of these pins that go along left to right on the positive are connected, and all of these pins on the negative are connected. So you can see that by the power supply strips. Basically, it's just one big piece of metal. And then going across, up and down, each row is connected. Now there's a channel in the middle here that divides the breadboard in half. So nothing on this side is connected to that side. So nothing on this side here is connected to that side. And what each of those little pieces of metal are is they just have these little clips that help hold your electronics. So as I slide it down in the hole, it's got this little piece of metal that is pinched onto it. And so all of that row is connected. See here. All right. So that is how a breadboard works. So coming back to our display. So what I'm going to do is I'm going to take my negative end and I'm going to plug it into the negative rail. Okay. And then I'm going to take my positive end and plug it into the positive rail. Okay. Now what I'm going to do is I'm going to take a white wire and I'm going to connect my row 13, which is my ground, right, the short side of the LED, and I'm going to connect it over here to my negative rail. Then I'm going to take this other wire and I'm going to connect it from row 15, which is the positive, the long side of my LED, and I'm going to connect it here. Whew. Okay, I just touched it for a second because it gets really bright. So what we can see there is right now, when I just touch that and it completes the circuit, that means electricity can flow all the way through. So it can flow through the red wire, then through the orange wire into the LED, and then back out to the ground. And that is a complete circuit. A circuit basically means a path for the electricity to completely flow through from the positive all the way to the ground. All right, but as you can see, this is really, really bright. So now let's get back to our resistors. Okay, so here is a resistor. This is going to resist or restrict the flow of electricity. So I'm going to plug this into the positive side. Okay, and then I'm going to, you can see I accidentally just touched that, and you can see it came on. Instead of touching it directly to the long rail, I'm going to put it into the 15th row and then into positive. So then we're going to connect that to the positive, and there we see. Now we see our LEDs not quite as bright as it was. That's because now the electricity is flowing from the battery pack through the red wire down this rail into our resistor, and then into the positive side, the long side of our LED. It's going through there, coming down to row 13, which is connected to ground. So now I want to show you. So this is actually resisting. Again, think of it as water flowing through a hose, and someone pinches that hose to resist the flow of electricity. So that's what a resistor does. So I'm going to take that resistor out, and I've got a different one here. I'm going to do the exact same thing. I'm going to plug this resistor into row 15, where our positive side of the LED is connected, and I'm going to connect this into the positive power rail. Okay. And I don't know if you can tell the difference, if that's dimmer or brighter. But let's try this again. Let me switch this. So this actually looks a little brighter to me. Let me switch it back to there. Yes. Now, so there's resistor number 1. That's the, actually that was the brown resistor. And this is the blue resistor. Now the color doesn't really have much to do with it. Okay, but you see that? That's our blue resistor, mostly blue resistor, versus our brown resistor. If you can tell, the blue resistor actually makes it brighter than the brown. And the reason being is that the brown resistor is actually providing more resistance. So, and I can actually show this. Watch if I connect them both. It actually brightens up. Now you might think that's weird, but what happens is electricity, similar to water, will always take the path of least resistance. What I mean by that is let me connect them both again. So I'm going to put them both into the power and then both into pin 15. So the electricity comes down, and it can go through this blue resistor, and it can go through the brown resistor. But almost think of the brown resistor as someone pinching that hose tighter. And imagine you have a hose that has a Y in it. Water comes in, and then it can go, when I say a Y, it can split, right? So the water can split out. It can go left and it can go right. And normally water would go equally out each side. But if you pinch off one side, not very much water is going to go out there, and the water is actually going to divert and go out the other side because it's easier. And that's the same kind of thing here. Here we're giving it a Y. The electricity can split. When I say Y, it's split. So the electricity can go either path, but it chooses to go through the one with less resistance, so we see the brighter light. So if I disconnect this blue resistor with the less resistance, you see it actually dims, because now it has no choice, but it has to go through the one with more resistance. And so resistance is measured in a unit called ohms. We said the pressure of electricity was measured in volts. The resistance of electricity is measured in ohms. The higher the ohms, that means the more resistance you have. So this is a higher ohm resistor. This is actually about a 10,000 ohm resistor. This is a 400. The blue one is a 400 ohm resistor. So that's why when we hook the blue one up, we see it get brighter, because it has a lot less resistance than the 10,000 ohm resistor. And now just to see the difference, again, if we forgot, if I go directly with no resistance, so I'm just going to use this wire so there's no resistance, it's super bright. All right. And actually, if I left that plugged in too long with no resistor, it could actually burn out the LED because the LED is not meant to go at 4.5 volts. I believe if I look at my spec sheet for this resistor, yeah, the blue LEDs are rated for 3.2 volts. So I think I already mentioned, right, that we've got 1.5 plus 1.5, that would be 3. And then we got another battery, so that's 4.5 volts. So it gets super bright when I go directly because we don't have any resistance and we're getting the full 4.5 volts into our LED, which is really only rated for around 3 volts. So that's where you'd want to use a resistor to protect it and make it last longer. So I could use this nice 400 ohm resistor to make it pretty bright, or I could switch it and use my 10,000 ohm resistor to make it a little dimmer. And of course, I could continue to increase resistance if I wanted it even more dim. So this is a very simple basic circuit. Hopefully you understand a little bit more about the way electricity works, and you understand about LEDs. They have a positive and negative side. Hopefully we understand a little bit more about resistance. And that is where I'm going to end this video today. Hope you learned something. Good luck and have fun.